Hello students, welcome to Vista's Learning. This is Shruti Nadiga, your chemistry tutor. We are in Vista's Learning where we provide the quality education for all. We are in 11th standard and we are doing about the chemistry. Which chapter? This is hydrocarbons where hydrogen and carbon combine together to form a series of compounds and we are learning about them. Right, what we are learning today? As in the last class, we have studied about the alkenes, right? Physical properties as well as the preparations. Now, we are going ahead with chemical properties of these hydrocarbons. In that, we have alkenes, right? So, this is our lecturing class 5. If you have missed any of our videos, you can browse into our web application www.v-learning.in. So now we are studying about the chemical properties of alkenes. So what are the chemical properties? Whenever we speak about chemical properties, we need to know. If you know the preparations, then the reversible reaction can be also the chemical properties of these alkenes. So we'll discuss how many chemical properties are there and what are the reactions we need to know. And here we are learning about Markonikov's rule. That is very much important, students. Mark it out. So alkenes are the rich source of loosely held pi electrons. Since we have the pi electrons, they can easily react and they can attract the electron cloud. The substances which are like attracted towards the electron cloud will come towards these reagents, right? So as we have already know that they can be easily reacted and they can be converted into saturated alkenes. So these are the unsaturated hydrocarbons which can be converted into alkenes, which are alkenes can be converted into alkanes. Saturated, unsaturated can be converted into saturated alkanes. Right. So that is the main property where we can study about that. Remember that alkanes converting into alkanes will give you first reaction. So here what happens? We have loosely packed pi bond and that can be used for addition reaction where electrophiles, as I said, electron with philic. Philic means to attract or love towards. Those reagents or substances which are attracting towards the electrons are called as electrophiles, and those electrophiles can be easily attracted by these pi bond or weak pi electrons, and that leads to the carbon-carbon double bond breaking to add the other byproducts such that we are adding the other substances or atoms or group of atoms to the double bond so that we get the other compounds, new compounds which is been formed. So that can be called as addition products or addition reaction. For example, if I have carbon-carbon double bond, I can add water to it and I can break this bond where one OH bond is being formed with the carbon atom and the other hydrogen. So likewise, we can add any number of other reagents, but we need to know that they should be the electrophiles. If they are electrophiles, they can be easily attracted towards these pi bonds. So some reagents also add by free radical mechanism that we'll study. Free radical mechanism means they'll be going homolysis. If you have a bond, double bond, here you'll be having each electron shared by the carbon atom, the bond will be taken, like it will be broken. The bond electron pair will not go to a single carbon atom. Instead, the bond will be broken in a such a way that the cleavage takes place. Homolysis means same electron, like equally it will be shared. So one electron will go to carbon, one carbon, the other electron will go to the other carbon. This will be called as homolysis. Here, that process, what it is been taking place, we call it as a free radical mechanism. And there are some other cases where you can have some other conditions, special conditions where the chemical reaction takes place for these alkenes. We'll study all these things today. So alkenes also undergo free radical substitution reaction. This is addition reaction. Substitution means removing one and adding other group or atom in the same place. For example, if I have hydrogen here. I'm removing this hydrogen and adding X group or halogen group, any other substance here. So that is called as substitution. If I'm breaking this and adding hydrogen on both sides, that will be called as addition reaction. Not only hydrogen, we can add any other groups or atoms. Oxidation and ozonolysis. Ozone means O3. So addition of this ozone, lysis always means breaking. So breaking this ozone and oxidation taking place, or addition of ozone, oxygen to the given alkanes by ozonolysis we'll study in this session. The first thing is that addition of dihydrogen. What is the first thing we learned? Addition reaction, substitution reaction, and we have the oxidation reactions. So we'll study about the addition reaction of these alkanes first. So alkanes add up one molecule of dihydrogen gas in presence of finely divided nickel, palladium and platinum. We know this because when the hydrogen is been added, we require these catalysts. Why? Because hydrogen will be having the covalent bond with the other hydrogen atom. So to break this bond, we require either platinum or nickel or palladium, such that they will break this bond and have a less attraction towards the hydrogen, such that this hydrogen can easily be attacked or attracted towards the carbon atom, which consists of double bond, and they can be easily added to the given compound. So we require these catalysts. Remember, nickel, palladium, platinum will be there when the reduction or addition of hydrogen has been taking place. Why do I say reduction? Because addition of hydrogen will be called as reduction. Addition of oxygen will be called as oxidation. Do you remember redox reaction? Good. So here we have ethene, where carbon-carbon double bond, and we have two hydrogen atom like this. This is the structure of ethene. What is this? C2H4 is ethene, ethylene. So we have two carbon atoms with one double bond, we'll call it as ethene. So this ethene, when added with the hydrogen, so hydrogen molecule will be added, what happens? This bond will be broken. So if I remove this bond and add one hydrogen on the each carbon atom. So now what do I get? This ene will be broken and ane is being formed. So this ethene will become now ethane. How? By addition of two hydrogen atoms. So C2H6 is the molecular formula of ethane. We get 3 plus 3, 6 hydrogen atom. Addition of hydrogen atom is this. Understood? This is the first member where we are adding this hydrogen. You can take any other members also. We can get the equations like this. Addition of hydrogen, breaking down of double bond, addition of hydrogen on each carbon atom. So addition of halogen. If you are taking addition of halogen, you should remember fluorine, chlorine, bromine, iodine, right? So here halogens like bromine or chlorine will be added up to the vicinal dihalides. It will be forming vicinal dihalides. If you are reacting alkene with bromine or chlorine, why I wrote this X2? Because they will be diatomic molecule, right? So you'll get bromine or chlorine in the diatomic molecule. So two chlorine atoms and two bromine atoms will be easily available and they can be easily added to the double bond. How? If I take the double bond like this, we'll be having hydrogen satisfying the tetravalency of carbon. Here what happens when we add bromine, we'll be having Br2. It will be Br, one single bond with the other Br. So this bond will be broken. One carbon will attract one bromine and the other bromine will go to the other carbon. So we get carbon-carbon single bond and one Br for the one carbon atom other Br for the other carbon atom. We have studied in the last or previous class that if you have the adjacent carbon atoms with the halides, then we call it as vicinal dihalides. Vicinal always mean adjacent carbon atoms having the same substitution. Then we'll call it as vicinal. Di means two, halides means halogen. So it is a vicinal dibromide. If I take chlorine, we'll get chlorides. Got it? So here's the equation, general equation, where ethene is being taken with the halogen X2, where you get this CH2X. This reaction will be like you will be having hydrogen. You can take carbon single bond, where we have X here and hydrogen. So this is how the structure is. C2H2, CH2X. For this carbon atom CH2X, CH2X. You can replace this also, no problem. While writing this equation, you can just take this. So here we have an example of propene, where this propene will be having the double bond for first carbon atom, and that will be reacted with the chlorine. So two chlorine will, this double bond will be broken, and these two chlorine will come here, and we get CH3 as it is, CH single bond, CH2 as we have, and one bond will be broken, right? So that will be forming one each carbon atom will be having one each chlorine atom bonded to it. So what is the name of this? It starts from here 1, 2, 3. So prop, all are single bond. So ane, propane, where you can see it will be a propane, and we have to give the suffix for the substitutions 1, 2 dichloropropane. So here you can see propane has been converted into 1, 2 dichloropropane. This is the vicinal dichloride. Next, the reddish orange color of bromine solution in carbon tetrahedral chloride is being discharged when bromine adds up to the unsaturated site. If you have the double bond or triple bond, what happens when we are adding this bromine to the unsaturated form, we get this reddish orange color which is been formed in presence of carbon tetrachloride. So that resembles that bromine has been reacting with the unsaturation, and this test can also be taken for the unsaturated compounds. For example, you have unknown substance and we don't know whether it is saturated or unsaturated, then the test can be held when that sample and the bromine is been added. If you get the reddish orange color, then it gives you the confirmation that the given sample contains multiple bond, double bond or triple bond. Okay, so that is where we have the reaction. Ethene, when reacting with bromine in presence of carbon tetrachloride, we get this dibromoethane, 1, 2 dibromoethane, and that will be having the color reddish brown color. So as we said, this can be used for the test of to get the clarification whether the given sample is saturated or unsaturated. So it can be used in the test for unsaturation. Addition of halogen to alkenes is an example of electrophilic addition. Why? Because they are attracted towards the electrons. They attract the electrons and they are attracted towards the electrons. So they are electrophilic substitutions or additions. So since this is addition reaction, it is not substitution. It is just breaking of bond and addition of chlorine or bromine or halogen. So we can call it as electrophilic addition reaction, where here the cyclic halonium can also take place, where we can get the ion formation. Next, we have the addition of hydrogen halides. We studied about the addition of hydrogen and halogen separately. Now we are studying the addition of hydrogen halide. This is very much important. Okay. So here hydrogen halide, it can be hydrochloric acid, hydrobromide, or hydrogen bromide, or a hydrogen iodide. When we are adding this to the alkenes, we'll get alkyl halide. That means if you are taking any of the R group with double bond, okay, this will be reacted with HX and we get this complete thing. One will be having H, other will be having X. So the complete thing will be called as R dash. Then that will be a alkyl group with X. So we can call it as alkyl halide will be formed. So when the alkene is being treated with the hydrogen halides, we get alkyl halide. The order of reactivity of this hydrogen halides. Why? Because we have chlorine, bromine and iodine. Down the group, size increases and hence the order of reactivity also differs. So as we know, the iodine is least reactive. So the bond which has been formed with the iodine and the carbon will be weak. So when it is weak, what happens? We can easily remove this. Either if you have hydrogen iodide, the bond between this hydrogen and iodine is weak here, so it can easily attract. So either of the side, you can remember that the order of reactivity will be high for hydrogen iodide because hydrogen and iodide can be easily removed because it is less electronegative. Whereas chlorine is more electronegative and the hydrogen bond and the chlorine hydrochloric bond, they are a bit stronger than that of HI, hydrogen iodide. So order of reactivity will be high for hydrogen iodide and then hydrogen bromide and then hydrogen chloride. Like addition of halogen to the alkenes, addition of hydrogen halide is also an example of electrophilic substitution because obviously we have the electronegative element, that is halogen. Okay. Addition reaction of hydrogen bromide to a symmetrical alkenes. Here you need to know what is symmetrical and what is unsymmetric. So here if I take the carbon-carbon double bond, right? So both the sides if I have same number of carbon atom, then this has been symmetric, right? If I have 3 carbon atoms on one side and 2 on the other side, then they are not symmetric. Got it? So first we are learning about symmetrical alkenes. If they are symmetrical alkenes, how does this addition of hydrogen halides will take place? So addition, reaction of hydrogen bromide to the alkene where it is symmetrical. So for the symmetrical alkenes takes place by electrophilic addition mechanism. How does it takes place? It takes place according to the electrophilic addition mechanism. What is the mechanism now? If you see, we have both the sides, same number of carbon atom. So the breaking of bond, one hydrogen will go and to the other carbon atom, bromine will be attacked. So simple, it is there. Either this is also correct or if bromine is going to the other CH2, Br, single bond CH3 because one more hydrogen is added. This is also correct, this is also correct because both are symmetric. Either of the side the addition of bromine is been taking place, there is no difference between the structures, right? So this is the addition reaction of hydrogen halide in symmetrical alkenes. So here also you can see this side two carbon atoms. So that is also balanced. That means it is been symmetric. So when adding to the hydrogen and bromine, either hydrogen is added here or here. There is no difference. So we get the equation with the product CH3, CH2, CH, CH3 and Br. Here Br is attached to the other carbon atom. Here we can write this like this: CH3, CH, single bond, CH and CH3. So what happens? This Br will be attached to this carbon atom, right? Because hydrogen is going to this carbon atom, so Br will be here. Don't think that it is here. Sometimes what happens, we can write like this, where you need to know this CH3 is there, right? So CH3, and this Br should come here. You can write like this, or we can also take this as, to eradicate the confusion, we can also take this as CHBr CH3. Okay. You need to know that Br is for the second carbon atom and not for first carbon atom, because the first carbon atom is already satisfied with three hydrogen atom and one carbon-carbon bond. Got it? Good. So next we have addition reaction of hydrogen bromide to unsymmetrical alkenes. For what? For unsymmetrical alkenes. You should know here we have the Markonikov's rule. What do you mean by this Markonikov's rule? So here, when you see this addition reaction of alkenes for the unsymmetrical alkenes, then the Markonikov's rule comes. There it states that when you have the unsymmetric, you can see here only one carbon atom we have here, whereas here on the other side of the double bond we have two carbon atom. If you pass the plane here, you can see 1 and 2. So it is not same number of carbon atoms on the either of the side. So this is called as unsymmetrical alkenes. And now addition of hydrogen and bromide to this. How can it take place? You can see that, ma'am, as usual, hydrogen will go to one carbon and bromine will go to other carbon. But here, when we are adding this, if I am adding hydrogen here and bromide here, this is one which we get, and the other one is that bromine here and hydrogen here. If we do like that, what happens here? If you are taking this, it will be counted that 1, 2, 3. So, 1 bromopropane. And if I am taking here, what happens? 2 bromopropane. So, you will get 2 bromopropane and 1 bromopropane. Which one is correct? Which is the major product here? That will be having a question. For that, we have this rule which is being followed. What is the rule? If you have this type of unsymmetrical alkenes, this bromine or the more electrophilic group will go and attack to the carbon atom where it is having the less number of hydrogen. I'll repeat it. The bromine or the electrophilic substitution, like we can get the electrophiles like this, either E minus or E. So these electrophiles will be attached to the carbon atom where the carbon is having the less number of hydrogen atom. In some other books, they will also give that the hydrogen will go and attack to the carbon atom where more number of hydrogen is there. Don't get confused with the hydrogen atom. Which you are referring is very much important. So generally take this electrophilic substitution or electrophilic substance or atom or group of atoms which is attacking or added to the substance or the double bond will go to the carbon atom where it is having the less number of hydrogen. So what happens here? This is the bromopropane. So bromine is going to the carbon atom. Which carbon atom? You have only two carbon atom you have to mind. It will be one CH2 one, or else the other one is CH. Right, because they both are in double bond here. So when they are in having the unsymmetrical alkenes, then if you get this chance of addition of this bromine, we need to think that which carbon is having less number of hydrogen atom. To that the bromine will go and attack. So we get these two where the first one is major and that is stable and that of second one. So according to Markonikov's rule, the first one is the major product. You should remember there is no catalyst used during this reaction. So Markovnikov is a Russian chemist where he framed a rule called Markonikov's rule. So the rule states that negative part of the adenum means the one which has been adding. If you take hydrogen and bromine, bromine is the negative, higher negative. You take like this, if the bond is been broken, we'll get H plus and Br minus. So this is the adenum. For this negative part is this Br. Addition of Br to which carbon atom, we need to remember that it has been attached to the carbon atom which possesses less number of hydrogen atoms. So the negative part of the adenum which is been adding to the given alkene or double bond will go to that carbon atom where we have the less number of hydrogen atoms. So thus we can say that the product one which we saw 2-bromo-propane is been expected than that of the other one according to Markonikov's rule. So in actual practice what happens, this is the principal product of the reaction. So next we have the mechanism. Hydrogen bromide provides an electrophile. So we have an electrophile H plus which attacks the double bond to form carbocation as shown below. So here we can see here we have this double bond where we have the symmetrical carbon atom. Here this HPr will be producing the H plus and that will be added to the carbocation to form the carbocation. So you will get the two different carbocations. So here CH3, CH2. This hydrogen is going to the first carbon atom. This is the mechanism where you can see. So if I just take a example of CH3, C double bond, C here CH double bond CH2. Okay. So we have the hydrogen bromide. This will be broken, the hydrogen bromide. So we'll get H plus plus Br minus. So first what happens, this H plus goes and attacks to the carbon atom where there is more number of hydrogen atom attached to the carbon atom and the less number we should not touch that. So what happens, you will get CH3, CH, this bond will be broken because this will be gone to get this, or else you can say like this, electron rich. So you will get this. So this is the bond. We have hydrogen with positive charge. So what this carbon do is that this carbon will take this double bond with the carbon atom. This carbon atom, if I name it as 1, 2, 3, the first carbon atom comes to the second carbon atom and says that, no, I want this double bond for some instant. Please give me that double bond. So he takes the double bond. Double bond contains 2 electrons. And hydrogen, if you see, hydrogen will be having 1 electron in the outermost shell. If it is being taken away by bromine, it will get 0 electrons. So hydrogen have no electrons. Hydrogen ion have no electrons now. So to get stability, it requires 2 electrons, right? So what happens in the bond? It will be having 2 electrons. One shared by this carbon atom, another shared by the other carbon atom. So both the electrons, this first carbon will take and give to the hydrogen. So now hydrogen will be stable. Since this carbon is helping that hydrogen, it comes and bonds with this carbon atom. So now what happens? That bond will be broken and will get the attachment with the H plus ions here. And when it is losing 1 electron, when it is been losing 1 electron, what happens to this carbon atom? Obviously, loss of electron makes you positive charge. So this will be forming CH3. It agrees, okay, anyway, you take the bond and it will become positively charged by losing this electron. So we have a single bond here and this carbon will have 3 hydrogen atom. So this is the intermediate which has been formed. And you know that in the medium, this positive charge is there and this negative charge is there. Whenever we have the opposite poles, they come and attract each other. So this bromine comes and attracts this carbon atom and hence we get the product as 2-bromo propane. This is one thing. According to the Markovnikov's rule, we have this mechanism. And this mechanism can also be taken place in such a way that it can act to any one of the carbon atom, right? So we get H plus Br minus, right? So what happens? We have CH3, CC double bond, CH2 here and one carbon atom. Now what happens? This H plus, this carbon, second carbon will say that now I'll take this bond and give to the hydrogen such that I will make the bond with the hydrogen. So it will have CH3 and we have this hydrogen, one hydrogen. This is also coming and adding with this. So it will have CH2 and here single bond because double bond is been broken and we have CH2 here, right? This CH2 will become positive charge. Why? Because that double bond, the electron of this first carbon will be attracted or taken away from this second bond and given to the hydrogen. Right. Since this bond is been given through the hydrogen, this second carbon atom, hydrogen attracts towards second carbon atom. If it is been given through the first carbon atom, hydrogen will attack the first carbon atom. Now what happened? It has been going to the second one. So the second carbon will be satisfied where the first carbon will have positive charge by losing the one electron which is been in the pi bond. So now we have the bromine which is present in the system. So negative and the positive, they get attracted and we get the product as CH3, CH2, CH2 and Br, which we can call it as 1-bromo-propane. Hope you understand this mechanism. The first step what you have to remember is this. First step is the hydrogen bromine. What is been forming? Hydrogen ion and bromine bromide ion. This is the first step. And the next step is that whatever the double bond is there, the hydrogen is attached to that. That is the second step. This is the first step. This is the second step. When it is been attacked, the one of the carbon atom will lose this electron and become carbocation. So if this is attacking to the first carbon atom, then second carbon atom will become positive charge by addition of this hydrogen. And in the system we have Br. So this Br minus attacks this carbocation and forms the bond with the carbon and hence the addition of hydrogen bromide to the alkene takes place in this mechanism. Got it? So what is this positive charge on the carbon? We call this complete molecule as carbocation. Positive charge is there, that is called as cation. If negative charge is there, we call it as anion. So carbon is having positive charge here. So we call it as carbocation. Got it? So in carbocations also we have primary, secondary and tertiary carbocations. Why? Because we know that carbon will be having primary carbon atom when it is been linked with the other carbon atoms. Primary, secondary and tertiary. So that also matters how this reaction is been, mechanism is been taking place. The order of reaction depends on the carbocations also. Hope you understand this. Good. So this is the mechanism as I said. So here when we are speaking about carbocation, I said primary, secondary and tertiary, right? So here the first one if you see, when the hydrogen is been attacking to the carbon atom according to the Markovnikov's rule, then we get the primary carbocation. And if it is, if the hydrogen is attacking to the carbon according to the Markonikov's rule, then we get the secondary carbocation. If it is according to the anti-Markonikov's rule, anti means opposite. So opposite to that of Markonikov's rule, then we get the primary carbocation. How to find out primary or secondary? You can see this carbon atom, it is been attached to only one R group or carbon group. That means it will be having the primary carbocation. The same thing if I take here, it is been attached to the two carbon atoms, so we call it as secondary carbocation. So here when you compare the primary and secondary carbocation is stable. So the reaction will be more favorable for forming 2-bromopropane according to the Markonikov's rule. If you take this primary carbocation is less stable and hence the minor products or very less product will be formed according to this anti-Markonikov's rule. Got it? Good. So here you can see the same thing, the secondary carbocation, that is the B product what we saw, is more stable than that of the primary carbocation. The former predominates because it forms the faster rate. Means the first one will be formed, this B will be forming more rapidly. Why? Because it is stable. Okay, and the rate is also faster for that reaction than that of the primary carbocation. The carbocation B is attacked by bromine ion to form the product, where you can see the product where we have the carbocation, bromine is added to that. So we get 2-bromopropane as a major product here. Next we have anti-Markonikov's rule. Here this can also be called as peroxide or Karash effect. They can ask you in the question, mention or give the reaction or mechanism for the Karash effect or reaction when the reaction has been taking place, addition of hydrogen bromide in presence of peroxide, or they can directly ask what is anti-Markonikov's rule, give an example. So in presence of peroxide, addition of hydrogen bromide to the unsymmetrical alkenes. You need to remember, students, these Markonikov's rule and anti-Markonikov rule will be only held for this and unsymmetrical alkenes. If you are going with the symmetrical, there is no problem wherever the bromine or the hydrogen is been attached to the carbon atom. But here, since it is unsymmetric, we have a problem where this carbon atom, this bromine atom should go and attach to which carbon atom? Either primary carbon atom or secondary carbon atom. So here we have in presence of peroxide, addition of this hydrogen bromide to the unsymmetrical alkenes takes place, like propane takes place contrary to the Markonikov's rule. This happens with the hydrogen bromide but not with the hydrogen chloride and hydrogen iodide. So that is the exception. This anti-Markonikov's rule can be taken in presence of hydrogen bromide, not with the in presence of hydrogen chloride or iodide. This reaction or addition was observed by M.S. Karash and F.R. Mayo in 1933 at the University of Chicago, and hence gets the name Karash. The reaction is known as peroxide or Karash effect or addition reaction anti to Markonikov's rule, or directly we can call it as anti-Markonikov rule. So here you can see we have this same propane where hydrogen bromide is added in presence of peroxide. Here we have taken the benzoyl peroxide, or you can take any of the peroxides. So those peroxides, mainly you need to remember this, the peroxide, or you can directly write peroxide in words. Both are fine. So in presence of this organic peroxide, we get the reaction as 1-bromopropane. This will be the major product for anti-Markonikov's rule. Whereas for Markonikov's rule, 2-bromopropane will be the major product. So in exams also they may ask you, giving the reaction alkene reacting with the hydrogen bromide. Anti-Markonikov's rule, major product, or Markonikov's rule, major product. or in presence of, they can just give you this, in presence of this they can give you peroxide. As I said, only peroxide can be also written. Either this has been written or this has been written. You need to know this is a benzoxide peroxide. So this peroxide or this has been written, you have to get the reaction according to the Anti Markovnikov's rule. What does the Anti Markovnikov's rule? It is been exactly opposite to that of Markovnikov's rule. So here what happens? The electrophile will go and attack to the carbon atom which is having more number of hydrogen atom. Got it? So what is the Markovnikov's rule? In Markovnikov's rule, the electrophile will go and attack to the carbon atom where it is having less number of hydrogen atom. So here mechanism again they have been showing according to the free radical chain. Peroxide effect proceeds from like using or via free radical chain. How does the mechanism take place? If you see here, we have the peroxide. So this peroxide will undergo the homolysis. What is homolysis? Or it is a homolytic cleavage. So what happens? You will be having the bond here. This electron and this electron which is been present in the bond will be taken back from each oxygen atom. So we get two radicals here, benzoxide radicals. So these two radicals, you can see one unpaired electron here. So that unpaired electron will be written as C6H5 dot. You can write it as C6H5 dot like this. This is called as radical. Right. So how many radicals will be formed like that? Here two radicals will be formed. In this, so I'll just show you how that radical will be formed. C6H5 if you have. First what happens? We'll be having, I'll show you here. So C6H5, C double bond O, and this O. This is one unit and this is another unit. C6H5. Okay. So what happens? This is a peroxide. Here, one electron will be here, one electron will be here. Each oxygen atom will be sharing its one electron each, and while homolytic cleavage takes place, they take back their electron. Okay, enough, we are being here. I'll take my electron, you take your electron and go. So what happens? What is being formed here? C6H5, C double bond O, and here this oxygen will have one electron which is being taken back. Right. So now this how many have been formed? Two such radicals have been formed. Okay. This again undergoes cleavage. How? You have the C6H5, C double bond O and O dot. And you have a bond between this carbon and this carbon atom. I'll just show you the carbon atom. One carbon atom here. C6H5, and this will be having double bond O. This will be having dot here, right? What happens here is that this oxygen will recommend that no, I am having only one. I want one more electron. Carbon, can you give me the one more electron so that we can have the bond? So what this carbon atom says is that no, oxygen is calling me. I want to go with that. Please will break up. So they have the mutual understanding. What happens here? This takes its electron back. This takes its electron back. So again, homolysis or homolysis or homolytic cleavage takes place. So the bond between this benzyl group and the carbon takes place. So what happens? This carbon will have this carbon-carbon double bond and one single bond with this, and this is having one electron. This is taking back its carbon electron, right? So that will take back and they will have a bond between. So now what can you say this C double bond O, we call it as carbon dioxide. So carbon dioxide will be released and this will be formed where you can see C6H5 and this will be having one electron now. And this we call it as radical, benzyl radical. Understood? So this is how the mechanism takes place. This is called as free radical chain mechanism, where you can see this peroxide will be having the cleavage over here. Cleavage over here, we'll get the homolysis and this product where this is again a radical and again this bond will be undergoing the homolysis and will get the benzyl with the evolution of carbon dioxide. Got it? This is the first initiation step. The first free radical is been produced. And the next one, you will be having the alkane group where we can get the alkane group here, CH3, C double bond, CH2. And we have one more single bond. What happens here now? So here we have the reaction like HBr is being added to this, right? So when in presence of the C6H5 radical, so now this will not be quite. This also requires one more electron because it is not stable. Either if it is positive or negative, it will attract the opposite charges. But if it is having only one electron, it will attract the other such that they will undergo the again homolysis and get the electron and they will have the bonding here. So what happens here? The reaction, homolytic cleavage takes place and one electron, it will be taking the electron. Again, it leads to the formation of radicals, free radicals, and that radicals will attack here either hydrogen and bromide and they form the bond here. So this will form the homolytic cleavage. So I'll just show you the first step. How does it takes place? As we know, C6H5 plus HBr. So it is a radical now. What does it do? It takes the homolytic cleavage. It leads to the homolytic cleavage of this HBr such that we get C6H6. So this H will be breaking up with the bromine and this will go and attack this C6. So we get C6 and we have hydrogen 5 there plus 1 is it? We get the benzene ring. So we get this as a product and this is stable now. I got my stability. I got the one more hydrogen. So I'm stable. We have the Br radical now. So this Br radical is active. It requires one more electron. So it goes and attacks the alkene group. So what happens? We have the alkene group CH3, CH2, double bond. We have CH here, double bond CH2. Plus we have the bromine radical. So this radical will come and attack. Here again it depends on the we have Anti Markovnikov rule. Since it is Anti Markovnikov rule, it will go to the carbon atom where it is having more number of hydrogen atoms. So what happens? Again here cleavage takes place. This first carbon and second carbon will say, okay, I have one more other friend, he is coming, so we'll break up. So they have been getting their electrons back and they will be linked to the bromine atom. So we get CH3, CH, and here this carbon atom will be having one electron and it will be forming the radical now. So one CH2 and Br. This Br is stable, right? So we have this radical which is been formed. Now this radical will be satisfied by the hydrogen which is been produced, the radical, and they form the bond. By this we get one bromopropane. Hope you are getting this, students. So as I said, we can also have according to the Markovnikov's rule that CH3, C double bond is there, right? So CH2, one hydrogen, that Br, this Br can also go to this according to the Markovnikov's rule, right? Then what happens? This cleavage will take place. So we'll get the CH3, CH, and here one Br and the single bond CH2 and this will be having the radical, right? small dot. Actually, radical will be given with the dot. Here, if I write the dot, you cannot easily recognize that. So, I am writing the cross mark. Okay. So, we have this where again this on addition takes place. Addition of hydrogen radical takes place. So, what happens? Adding with the hydrogen radical with C6, CH3, CHBr and CH2, the addition of hydrogen, we get CH3, CH, the Br and CH3. So this is how the mechanism takes place. Hope you are understanding the students. Any doubt? I'll just give you the first thing. What happens? Peroxide will be there. So this peroxide will form the benzyl radical. How the benzyl radical is being formed? We can just take OOR like this, okay? Or else C6H12 will be having first step C6H5, C double bond O and O, C double bond O, C6H5. Okay, so homolytic cleavage happens here. The second step, what happens? C6H5, C double bond O, O will be there. So it will be having the radical, and this radical, the bond will be undergoing the cleavage and the bond will be shifted to the carbon oxygen. So we get C6H5 radical, that is benzyl radical with carbon dioxide released. So two carbon dioxide molecule and two benzyl molecule. And here the next one will be having this C6H12, which is C6H5 radical, which is going with the hydrogen bromide. Here again the homolytic cleavage takes place. So we get the C6H6 plus Br radical. Got it? So the next step, what happens? That bromine, if you have CH3, I'm just taking an example, double bond. What happens? That bromine will attack to either of the carbon atom. So Br, and thus again cleavage takes place, and we'll get two types here, either here or here. So we have CH3, C, if the Br is attacking here, single bond, and we'll have a radical over there. And that radical will be added with the H plus, and we'll get the reaction addition of hydrogen bromide done. Hope you are getting this point. So here, if you are adding the other bromine, so you can again take this hydrogen bromide will be splitting, and here instead of H, you can add HBr which is present, that will again undergo the breakage, and one more Br radical will be formed, and that will be again coming as the addition reaction for this. So it will be keep on reacting. Right. At the end, what happens? We have to stop this. So Br can attack and you will get a bromine molecule, or Br can attract with the hydrogen which is been present, the hydrogen free radical which is present in the system, and form the HBr again, or it can react with this and form the product. Hope you understand this, students. Any doubt? Good. Next, the peroxide effect is not observed in addition of hydrochloric acid or hydrogen iodide, right? So what happens here? We have the hydrogen chloride bond which is very strong, where we can see 430.5 kilojoules per mole than that of hydrogen bromide, where hydrogen bromide is 363.7 kilojoules per mole. So what happens here? Due to the strong bond, it cannot cleave. The cleavage cannot be possible. So what happens? The homolytic cleavage cannot be easily formed between hydrogen and chlorine, whereas For hydrogen and bromine, it can be possible because the bond strength will be very stronger for hydrogen chloride than that of hydrogen bromide. So it is not cleaved by the free radical, whereas for hydrogen iodide, what happens? It will be having a very weaker bond, where you can see, excuse me, so 296.8 kilojoules per mole. And you can also see iodine free radicals combines to form the iodine molecules instead of adding to the double bond. Instead of they are adding to the double bond, they themselves add up with the other molecules of iodine, and so the reaction is not, this mechanism is not valid for hydrogen chloride and hydrogen iodide. Why for hydrogen chloride? Because it is having a stronger bond. So if you have a stronger bond, we cannot easily go ahead with homolytic cleavage. And if you are having the hydrogen iodide, it is weak, but it takes place the free radical. If we have the iodine free radical, that will add up with the same molecule, iodine molecule, instead of going with the double bond. So this is why we are not using, or this peroxide effect or Karash effect or Anti Markovnikov's rule is not being valid for hydrogen chloride or hydrogen iodide. So next we have the addition of sulfuric acid. So as we know, sulfuric acid also contains the electrophile in them. So it can also be added easily to the reaction of alkenes, where the double bond can be removed and this sulfonic group can be easily added. So cold concentrated sulfuric acid is added to the alkenes in accordance with Anti Markovnikov's rule to form alkyl hydrogen sulfate by the electrophilic addition reaction. Electrophilic, you need to remember, that means the electrophile is been attached, like it is been attracted. In sulfuric acid we have hydrogen sulfite, right? That hydrogen sulfate will be added to the double bond and will get a addition of that electrophile to the double bond. So here you can see CH2 double bond CH2. For this double bond we have the addition of, this is the structure of sulfuric acid, where it can give one hydrogen atom and two hydrogen atom. So when this reaction is been taking place, we'll get one hydrogen atom which is been going to one carbon atom, and the other group, if you take this, we can divide it over here. So we get H plus ions and HSO4 minus ion. So as we have the positive and negative charge, one hydrogen will go to the one carbon atom and the bond will be shifted. The bond will attract this positive charge and this negative charge will attack this other carbon atom. So first thing, the negatively charged particle will be attacking the carbon atom because it is the electrophilic addition reaction. So we can add this negative charge and then hydrogen can be added. Got it? Or else when hydrogen is been added, the bond will be shifted towards and this will become positively charged. So HSO4 minus, this can be attacked here. So ethyl hydrogen sulfate is been formed. We can see one hydrogen is been shifted here, we get CH3 and CH2, to that we have this whole HSO4 which is been attached. So we get the ethyl hydrogen sulfate. Here again you can see the propene. One propene or prop, one ene is being used. By the addition of this, we can either get this, or this is according to the Markonikov's rule. So whenever we have the addition of sulfuric acid to the unsymmetric substance or unsymmetric alkene, what happens? You need to remember, it undergoes the Markonikov's rule. According to the Markonikov's rule, what happens? According to the Markonikov's rule, electrophile will attack to the carbon atom which is having less number of hydrogen. So here the middle carbon atom or the secondary carbon atom will be having less number of hydrogen atom, and hence the sulfonic group or hydrogen sulfate group will attack to this carbon atom, second carbon atom, and the hydrogen will attack to the first carbon atom, where this leads to the formation of propyl hydrogen sulfate. So this is the addition of sulfuric acid to the alkenes. Next we have the addition of water. So when we add the water molecule, what happens? So in presence of few drops of concentrated sulfuric acid, or we can say acidified water, so alkenes reacts with water to form alcohols in accordance with the Markovnikov's rule. So even addition of water is undergoing according to the Markovnikov's rule. You need to remember, students, Markovnikov's rule and the anti-Markovnikov rule is very much important. What does the Markovnikov rule says? The electrophile will go to the carbon atom which is having the less number of hydrogen atom, whereas in anti-Markovnikov's rule the electrophile will go and attack to the carbon atom where it contains more number of hydrogen atom. So these all things, addition of these all water or sulfuric acid will undergo according to the Markovnikov's rule. So we can see here CH3, CH3 and we have CH2. So this is unsymmetric molecule or alkene. So for here what happens when you are adding the water, why we are writing H plus? We said that acidified water, right? So since it is been acidified water, we have the H plus ions here. Here what happens? We have H plus and OH minus ions. So we get the answer like we have this CH3. So here we have CH3, C, one more CH3 and we have a single bond with CH2, right? So one hydrogen will go to this and the other will come here. This is according to the Markovnikov's rule. You can ask me, ma'am, we can just write OH here and H here. Yes, that is the opposite to that of Markovnikov's rule, right? As we state that addition of water undergoes or it is been obeying the Markovnikov's rule, you need to remember that OH minus is the electrophile and so electrophile should go to the carbon atom where it is having less number of hydrogen atoms. So if you see here, we don't have hydrogen atoms here. Here we have two hydrogen atoms. So OH group should go to the carbon atom. This is the tertiary carbon atom. So we have OH attacking to the tertiary carbon atom. So how the product can be written? We have CH3, here CH3 and one more CH3 with OH. So the product, when the addition of water takes place for this substance 2-methyl propene. So 2-methyl propane will have the addition of water and we'll get 1, 2, 3. So propane and we have alcoholic group. So alcoholic group will be having the suffix as OL. So propane to which carbon atom? To the second carbon atom. To all. And it is not finished. We have one more substituent here or branch here. So it will be 2-methyl. So we can write it as 2-methyl propane to all. What is this? 2-methyl propane to all is the name for this substance. Next, oxidation. What do you mean by oxidation? Addition of oxygen. So alkenes on reaction with cold dilute aqueous solution of potassium permanganate, what we call it as Bayer's reagent, will undergo the vicinal glycols. Vicinal means adjacent carbon atoms. Glycols means will be having OH groups attacking to the carbon atom which are adjacent to each other. So OH group is attacking to the adjacent carbon atom and we'll get this by potassium permanganate. We are taking cold dilute aqueous solution of potassium permanganate. As we know, potassium permanganate is a very good oxidizing agent or reagent. We need to know that what reaction we have to take place and how much. So if it is dry or heat, then more oxidation takes place and or the carbon can react with oxygen to form carbon dioxide also. So to know that we need to have certain conditions. What is that? Cold, dilute and aqueous solution of potassium permanganate will be used, and if you are using this in presence of alkene, then we'll get the vicinal glycols. So decolorization of potassium permanganate solution is used for the test of unsaturation. When we know potassium permanganate is a light purple color, right, or violet color. If you have the violet color of this KMnO4 and after the reaction if it is been decolorized, then we can say that potassium permanganate is been reacted with the alkene produced, and the substance, if we doesn't know the substance, we can say that the substance is alkene or alkyne because it has been reacting with the KMnO4 and the color has been changed. So the given substance might be unsaturated one. Here we have the substance propene. When it is been reacted with the dilute KMnO4, we get the propane 1, 2. We can just take propane instead of this E. Can take propane 1, 2 diol, where we get this bond broken. This bond will be broken and we'll get here OH, OH group. So this can also be called as glycol. And since it is attached to the adjacent carbon atom, we can call it as vicinal glycols. So here in this process, you can have CH3, the same bond will be broken and OH, OH group. So CH3, CH3, CH, CH, OH is been attached here. So OH in the bracket. You can just write this OH in the bracket and single bond, and we have the CH2 and OH. So since we have 1, 2, like 1, 2, 3, we cannot come from there since we are having the double bond on the other side. We can name like this 1, 2, 3. So 1, 2. So first carbon atom and second carbon atom is having OH group. So 1, 2, 3 is a propane. Propane 1, 2. We cannot just say all because we have 2 and OH group. So we have to say diol. So propane 1, 2 diol will be formed in this process. Hope you are understanding this. Any doubts, students? Got to know, right? So here we can just write this with another example, where if I take the example of CH2 double bond CH2. So in presence of water, that is, we have the aqueous solution. So we are taking H2O and KMnO4 at certain temperature around 273 Kelvin. So what happens here? The product what will be formed? This will be having OH which is been attached here. You can see water molecule and one oxygen from the KMnO4, right? So what happens? 1 O, 1 O. So 2H. So we'll be having the OH, OH. So 2 OH group will be produced in this reaction. So what happens? We'll get the reaction as CH2 single bond CH2, where each one will have the OH group like this, and this we can call it as 1, 2 diol. For what? We have ethyl. So ethane 1, 2 diol, or generally we can say this as glycol. We call it as glycol. Notice? So they can ask you, give the production of glycol according to this oxidation of alkene, right? Or alkene when reacted with the cool KMnO4, what happens at 273 Kelvin? So next one we have acidic potassium permanganate or acidic potassium dichromate. Here you need to remember acidic potassium permanganate, and there it is called aqueous potassium permanganate. So if you are taking potassium permanganate with different medium, it will be having the different product which is been formed. So here we have the acidified potassium permanganate and acidic potassium dichromates oxidizes alkenes to ketone, or it depend on the nature of the alkene. If it is a secondary alkene, we get ketone. If it is a primary, we will get a aldehyde. So we'll just check out here. We have the double bond here where 2-methyl propene is been formed. When it has been reacted with KMnO4, we get propane 2-one. So what happens here? The bond will be broken here. We'll get oxygen to this, and this will be taken away as a carbon dioxide and water molecule. This will get completely decomposed. So this is how we get the reaction. So here what happens? One complete chain will be disconnected. So this is a but 2-ene where it has been reacting, and here it has been like the bond will be broken at this double bond. So when here it is been broken at the presence of acidified KMnO4, what happens? The CH3 CH, this double bond will be for oxygen atom. So what happens here is that here I'll write over this CH3 CH single bond double bond CH single bond CH3, right? So this is the substance. So here the bond will take place, the cleavage will take place. So when it has been taking place, since they both are of same, we'll take one of them. So CH3, this carbon atom will get oxidized in such a way that it will get double bond with oxygen, and one hydrogen will be there, right? That will be converted into OH group. So it completely oxidizes and gets a carboxylic group. So we get here ethanoic acid. So you need to know that if it is having one carbon atom at the end in between the bond, then the bond will cleave, and this carbon will undergo complete oxidation and gets carbon dioxide, and hydrogen will undergo complete oxidation and gives you water molecule, whereas this group, R group, will give you the ketone. Since it is having R, if it is having H, then it could have been converted into the carboxylic acid. Since it is a tertiary carbon, the way the cleavage is been taking place, this is a tertiary carbon. So what happens? That will undergo the oxidation to give propone, means ketone will be formed. Next we have the ozonolysis. Ozone, we know O3. Lysis means breaking. So breaking this ozone will get the oxidation done. So ozonolysis of alkene involves the addition of ozone molecule to alkene to form ozonide, and then cleavage of the ozonide by zinc in presence of zinc and water to form smaller molecules. The reaction is highly useful in detecting the position of the double bond in alkenes and the other saturated compounds. Means if we are undergoing this, we can easily identify which carbon atom is having the double bond in this process. So here we can take an example of ozonolysis where we can take carbon-carbon double bond. So I'm taking an example of CH3, CH double bond, CH2 in presence of ozone. So as we say in presence of ozone, we have O3. So how does the reaction takes place here? Here we have the CH3 as it is, where we have the double bond carbon atom. This double bond will be broken and will have the addition of ozone, O3 there. How it will be formed, you know? I'll write here so you can understand it better. So we'll be having CH3 and this CH group and this CH. So double bond we have, okay. So this bond will be completely broken. One bond will be broken and we'll get one bond formed here for each carbon atom where oxygen is present. Okay, and the other bond will be also broken and we get the other bond with these carbon atom formed like this. So it has been satisfied with this tetravalency. So this is called as ozonide. So this is the first step. When the addition of ozone is been taking place for the double bond, what happens? The double bond will split and will get one oxygen like this. The other oxygen will be added here. We know it is ozone is O3. So 3 oxygen atom will be connected to the double bond like this. So ozonide has been formed. The next step is this. This is reacting with zinc in presence of water. So how to write that? As we know, this is formed, right? So when this is been formed and reacting in presence of zinc and water, what do you get? The bond breaks. So one bond breaks and you will get the CH3CHO. What is that? What can we call this as? We can call it as aldehyde. So the other carbon atom CH2 you will be having, right? So this CH2 will have one molecule. The cleavage takes place like this and the other cleavage takes place and this oxygen will be taken out. So we'll be having the CH3CHO and HCHO. Two group. If it is some other R group, then we'll get other than formaldehyde, we'll get the other R group alkyl halide. So we'll get the alkyl aldehyde. So here it is a methanaldehyde. This is the methanaldehyde. This is the ethanaldehyde. So aldehyde you can represent with Al, methanal or ethanal. So ozonolysis leads to this. So if I am taking the example of CH3 C double bond here like this reacts with ozone to form the ozonolysis. Like in presence of ozone, we'll get the ozonide which is been formed, and this leads to the cleavage of the bond in presence of zinc and water molecule where we get the CH3 and CHO plus this HCHO will be formed. This is the formaldehyde and the methanol. Methanol and the ethanol will be formed. So next we have the polymerization. Hope you all understand this, students. What is polymerization? What do you mean by polymerization? So if I'm taking this as an example, as I said the previous one, I'll just go with the previous one. This, we have one R group, right? So if instead of this, if I have the other R group, if I have instead of this hydrogen, I have the other CH3 group, then what shall I get here? So if you have the R group and the ozonolysis takes place in the same way, where this hydrogen will be replaced with R group, that we can say it as CH3 group. And when it is being formed, here also, instead of this hydrogen, we'll get R group, that is CH3 group. So when this bond has been broken, we'll get a double bond. So this R, C double bond R, this is called as ketone. Right, this is the ketone which has been formed. So what we can say, aldehyde is been formed or ketone is been formed by this process. It depends on the carbon which has been attached. Either it is primary, secondary or tertiary. But if it is primary, we'll get the aldehyde like this. So next we have the polymerization. What do you mean by the polymerization? We have already studied about this, right? So as we know, the polythene bags and all the plastics what we are using, they are the polymers. Generally, they are made up of these alkenes. So polyethene. So we get this polythene. Polythene bags we say no. Poly means many. Ethene means it is polyethene. So ethene means carbon-carbon double bond with two high carbon atoms. So this is the ethene. So this polymerization will take place and it gets the polymer which is named as polyethene, and short form or commonly we'll call it as polythene. So polythene bags and other substances will be using that, right? This has been obtained by combination of large number of ethene molecule at a higher temperature, high pressure, and in presence of some of the catalyst. Right, the polymerization will take place, and the large molecules thus obtained are called as polymers. And this reaction, where the process of polymerization or attaching of this single units in to form a longer chain, will be called as polymerization, and that simple compound which is been added continuously will be called as monomer. So here is an example. This is the polyethene, and N means any number of molecule you can take that will be producing the polythene. So how does the polythene is been formed? We have the CH2 double bond CH2. Right. We have one more CH2 double bond CH2. So what happens here is that this bond will be shifted here. So we get CH2 single bond, and this will be shifted to the other double bond. So likewise, we'll get the CH2, 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 and it will be continuing n number. How many number of ethene molecules we are taking will get such a lengthier one. So we can write this in the bracket and write n. That means that number of, if it is 10, then we'll be having 10 here. 10 molecules if you take, we'll get a chain of 10 molecules, and we can call it as a polythene of a polymer of polythene, ethene. So likewise, we have the propane. Here what happens? We'll get a similar one, but here the bond will be with the other molecule. If I am taking CH3, CH double bond CH2, right? This hydrogen will be, methyl group will be shifted here, and this will be shifted at the top because it is not going in the undergoing any of the reaction, right? So it will be attached to the other CH group, CH2 group, and single bond. Again, we'll be having the CH group here with one CH3, and this will be again bonded with the other bond which is not having the double bond. So this double bond will be shifting continuously. This is how the polymerization takes place, and you need to remember it will be having a high temperature, high pressure, and we have the catalyst to take place this polymerization. So as we know that these polymers are manufactured of plastic bags, and we have the quiz bottles, even in the refrigerating dishes what you keep in, we have the toys, pipes, radio, and many things will be using this plastics, and even in TV cabinets will use this polymers. One thing we need to know, these plastics are not recyclable, or these plastics are not biodegradable. So we have to reduce using this plastics. Polypropylene is used for the manufacturing of milk crates, and we have the plastic buckets which we are using with the polypropylene, and some of the molded articles. Though these materials have now become common, excessive use of ethene and polypropylene is a matter of great concern for all of us. We know that it is not biodegradable. We don't know where to use it or where to throw it out. So we need to reuse it and reduce the manufacturing of this. When we will reduce the manufacturing of these polythene bags or plastic things, when we are accumulating it more, or if we are using less, then we can reduce the production, and then we can be helpful for this ecosystem not to disturb. As we know that plastic things are disturbing our environment, right? So to reduce that, we can reduce usage of this polythene or polypropylene substances. Hope you enjoyed this class, friends. Thanks for watching Vista's Learning. As we say, if you have missed any of the videos, you can get back to our web application www.v-learning.in, and if you have any doubts, you are always welcomed so that we can understand your doubts, and we are always here to solve your problems, where we Vistas Learning provide you the quality education for all. Thanks for watching Vistas Learning.